Welcome to the deep dive. So you want to understand AI, right? Not just the hype, but the real deal. You want to know where it came from and where it's headed, and how it's going to affect all of us. To get to the bottom of it, you sent us a mountain of articles and research.
A fascinating mix, really. Everything from the very first ideas about thinking machines to predictions about superintelligence.
Like, what does it even mean for humanity if we create something smarter than ourselves? It's wild. This deep dive is going to be like a time machine and a crystal ball, all in one. So our mission is to cut through all the noise and really understand AI, its potential and its challenges.
We're going to tackle those big questions for sure. But before we get ahead of ourselves, maybe we should start with the basics. I mean, what are we even talking about when we say artificial intelligence?
Right, right. Sometimes I feel like AI is just this buzzword, like it's some kind of magic, but what is it really at its core?
Well, I think at its heart, AI is about trying to give computers the same abilities as our minds, to make them think like we do.
So it's more than just building a supercalculator. It's about like replicating the human mind.
Yeah, exactly. It's not just about the physical machine, the hardware. The real key is the software, the instructions that tell the computer how to process information. We call this the virtual machine.
Virtual machine. Okay, now that sounds a little philosophical. Can you break that down for me?
Think of it like baking a cake, right? The ingredients are the hardware, but the recipe, the steps you follow, that's the virtual machine. That's what determines what you end up with, the final cake. So in AI, the virtual machine, that's what dictates how the computer thinks.
I like that. So it's not just the parts. It's how those parts are put together and what they're told to do. That's fascinating. But to really get a handle on where AI is going, we probably need to look at where it came from. Some of the articles you sent, they take us all the way back to the 1840s.
Long before the first computers. Amazing, isn't it?
I had no idea AI went back that far. What were people even thinking about back then?
Well, there was Ada Lovelace, a brilliant mathematician and writer. She worked with Charles Babbage on this thing called the analytical engine, kind of a mechanical ancestor to the computer.
Oh, yeah, Babbage's analytical engine. I've heard of that. It was this huge project that never actually got built, right?
Yeah, but Lovelace, she saw its potential. She imagined it doing way more than just crunching numbers. She thought it could compose music, express scientific facts, even create art.
Wow. Over a century before computers even existed. So she was laying the groundwork for machines that could think creatively.
Absolutely. She saw computation as more than just calculations, but as something that could touch on what we call intelligence. She was way ahead of her time. And then, of course, there's Alan Turing, the godfather of computer science.
Oh, right. He's the one who cracked the Enigma code in World War II.
That's him. But his contributions to AI are even bigger. He took the theoretical idea of computation and figured out how to build actual machines that could do it. He laid the mathematical foundation for everything we do with computers today.
So he took us from ideas to real-world machines.
Exactly. And on top of that, he was already thinking about how we'd know if a machine was really intelligent. That's where the famous Turing test comes from.
The Turing test. That's where you have a person talking to a machine and a human. If they can't tell which is which, then the machine is considered intelligent.
That's the idea, yeah. It's a thought experiment, but a really powerful one. People are still arguing about it today,
Yeah.
It makes you think about what thinking really means.
So we've got Lovelace and Turing setting the stage for AI. What happens next?
Well, in the mid-20th century, things really started to heat up with the work of Warren McCulloch and Walter Pitts.
This is where it starts to feel futuristic. What did they do?
They showed how logic, the building blocks of reasoning, could be represented using networks of these simplified brain cells, neurons. It led to two big branches of AI research: symbolic AI and connectionism.
Okay, hold on. What's the difference between those two?
So symbolic AI is about using symbols like words and numbers to represent knowledge and solve problems. Kind of like writing a computer program, but with languages like Prolog or Lisp.
Like teaching a computer to think using a set of rules and symbols.
Right. And then you have connectionism, which is all about building artificial neural networks, like the structure of the brain.
Oh, so that's where we get deep learning. I hear that everywhere these days.
Yep. Connectionism is about building networks of these interconnected nodes that process information, kind of like neurons in our brains.
So basically building artificial brains, that's mind-blowing. But did these early researchers actually create intelligent machines?
They made some pretty impressive programs. Like in the late 1950s, Arthur Samuel built this checkers playing program that actually learned to play better than him.
Wait, the program taught itself to beat its creator. That's crazy. Like it developed its own mind.
It was a big moment, captured everyone's imagination. And then there's the logic theorist program, developed by Alan Newell, Cliff Shaw, and Herbert Simon. It could actually prove complex mathematical theorems, sometimes even better than famous mathematicians.
Wow. These early programs were already doing things we thought only humans could do.
They were. And it sparked a wave of optimism, mixed with a little bit of fear about what AI could become.
Which brings us nicely to the next big thing,
Yeah.
the cybernetics movement. What was that all about?
Cybernetics was this fascinating movement in the mid-20th century. It was all about understanding systems, especially biological ones, and how they regulate themselves through feedback.
Okay, like a thermostat that keeps your house at a constant temperature.
Exactly. Cybernetics was all about these feedback loops and self-organization in complex systems.
So how did that tie into AI?
Well, think about it. Norbert Wiener, one of the founders of cybernetics, he argued that intelligence itself, human or artificial, is all about information processing and feedback, right?
So seeing the brain as this complex system that's always adapting and learning.
Exactly. And this emphasis on feedback, it led to some really interesting new approaches in AI research.
Speaking of which, I have to ask about those tortoise robots. I read about those. Sounded incredible.
Yes. Gray Walter's tortoises. These little robots built in the 1950s, but they were doing some surprisingly complex things, like they could seek light, avoid obstacles, even learn from their surroundings.
Hold on. Robots from the 1950s could do all that.
Yeah, it was groundbreaking. Walter showed that even simple robots could seem intelligent, like even lifelike. And he used principles from cybernetics to do it, feedback and self-organization.
So these robots were like artificial creatures adapting to their environment.
In a way, yeah. They were early examples of embodied AI, the idea that intelligence isn't just thinking, but about interacting with the real world.
Wow, so we've got these different strands of AI developing. Symbolic AI, connectionism, cybernetics. Were they all getting along?
Not exactly.
Huh.
It felt more like separate camps, each with their own methods, and, let's be honest, a bit of competition.
Like competing schools of thought, all trying to solve the puzzle of intelligence their own way.
You got it. Which, in a way, reflects how complex intelligence really is. Lots of different ways to approach it.
Yeah, that makes sense. It's like everyone's trying to climb the same mountain, but taking different paths. And speaking of different paths, one of those paths leads us to the big question, the singularity.
Yes, the singularity, where AI becomes smarter than us, an intelligence explosion, all sorts of predictions about what happens then.
This is where things get really interesting, maybe a little scary too. The idea of superintelligent AI. It's both fascinating and kind of unsettling.
It definitely gets people talking. Some people think it's the answer to all our problems. Others are really worried about what could go wrong.
Like a fork in the road for humanity, and we don't know which path is the right one.
It's a powerful image. To understand the singularity, we need to hear from both sides, the believers and the skeptics, which is exactly what we'll do in the next part of our deep dive.
All right, so we've explored the roots of AI, from Ada Lovelace's vision to Turing's incredible work and all the fascinating stuff happening with cybernetics. But now it's time to talk about that elephant in the room, right? The singularity.
It's a pretty captivating concept when AI becomes smarter than humans and then, boom, an intelligence explosion. Who knows what could happen?
It's like trying to predict the weather 1,000 years from now. The rules are totally different, and there are some big names attached to this idea, right?
Oh, yeah. One of the key figures is Ray Kurzweil, the inventor, futurist, author. He's got this idea called the law of accelerating returns.
The law of accelerating returns. Okay, I'm listening.
It basically says that technology doesn't just improve in a straight line. It gets faster and faster. Think about computers, how much they've changed in just a few decades.
It's crazy, right? What used to fill a whole room now fits in your pocket.
Exactly. And Kurzweil says that this acceleration is going to keep going, to the point where progress is happening so fast we can't even wrap our heads around it.
So like a snowball effect.
Huh?
The more it rolls, the bigger and faster it gets.
Perfect analogy. And Kurzweil, he thinks this applies to AI too. He predicts it will have artificial general intelligence, AGI, by the 2030s. So that's AI that's as smart as humans across the board.
Wow, 2030s. That's not that far off. And then what? What happens after AGI?
Well, Kurzweil thinks AGI is just a stepping stone to the singularity. He says we'll hit that by the 2040s when AI leaves us in the dust, intelligence-wise.
And that's when all those crazy predictions about the future come in, right? The stuff we can't even imagine.
Right. He thinks we'll merge with technology. No more limits from our bodies. Maybe even digital immortality. Uploading our consciousness into computers. Solving all the world's problems. Even exploring the universe in ways we can't even dream of.
It's both exhilarating and terrifying at the same time. It makes me think of those sci-fi movies where humans and machines are basically the same thing.
It's definitely a mind bender. But Kurzweil isn't the only one thinking about this stuff. Werner Vinge, computer scientist, sci-fi author, he actually coined the term singularity. He's written a ton about it.
What's Vinge's take on it? Is he as optimistic as Kurzweil?
Vinge, he's a little more cautious. He sees the potential for amazing things for sure, but he also worries about creating something so powerful that it gets away from us. He sees the singularity as a point of total uncertainty. Like it could be amazing or it could be disastrous.
So it's not all sunshine and roses, like we could create something we really regret.
It's definitely a possibility we have to consider. Even I.J. Good, the mathematician who worked with Turing, he was already talking about this back in the 60s. He said an ultra-intelligent machine could design even smarter machines. Right. And then whoosh, an intelligence explosion that spins out of control.
It's like opening Pandora's box. Once it's open, you can't close it.
Exactly. A lot of AI researchers are worried about that. They're looking into friendly AI. The idea is to design AI systems that are on our side, even if they're smarter than us.
So not just making AI smart, but making it ethical. AI that helps us, not hurts us.
Yeah, that's the goal. It's a tough problem, but it's something we have to figure out, especially if we want to handle the risks of the singularity.
It's like trying to write a rule book for a being that's smarter than you are.
It is humbling, isn't it? Shows how important it is to be careful with AI and think about what could happen.
We need to be ambitious, but also cautious, right? Push the boundaries, but be aware of the risks.
Exactly. And while the singularity might seem like something from the distant future, every choice we make today is leading us closer to it or further away.
So it's not just some theoretical future we're talking about. It's about the decisions being made right now and how those decisions could shape the future for generations to come.
Right. Every choice matters. And that brings us to a really important question. Superintelligent AI taking over the world, that's a scary thought. But are there more immediate concerns we should be worried about?
That's a good point. The singularity can feel like something out of a movie, right? What are the real-world problems AI is causing right now?
Well, for starters, technological unemployment. AI and automation are already replacing jobs in a lot of industries.
And it's not just factory workers or cashiers, right? The articles you sent, they mention middle management jobs, even professional jobs like lawyers and accountants.
Yep. AI is getting really good at doing complex stuff. Stuff we used to think only humans could do.
So it's not just about physical labor being replaced by machines, it's about mental labor too, right? Like thinking, problem solving, that kind of thing.
Exactly. AI can analyze huge amounts of data, find patterns, make predictions. It's really good at it. And that's going to have a huge impact on work.
It makes you wonder what jobs are even going to exist in the future, right? And how we're going to prepare people for them.
It's a huge challenge for society, and we need to start figuring it out now.
And it's not just about jobs, right? There are ethical concerns too.
Oh, absolutely. One thing that's worrying people is using AI in jobs that require empathy and care, like taking care of the elderly or raising children.
The research mentioned things like AI companions for older people and robot nannies. Sounds helpful, but it's also kind of disturbing.
Yeah. Can we really let machines provide that kind of emotional support, even though they don't actually understand feelings the way we do?
It almost feels like we're dehumanizing people, replacing real human connection with something artificial, even if it's well-intentioned.
It's a valid concern. Makes you think about what it means to be human, to care for each other, and what role technology should play in our relationships.
Like we're in uncharted territory and we need to tread carefully.
We do. And there are other ethical concerns too, like the possibility of AI becoming biased.
Biased? How can a machine be biased? Algorithms are supposed to be objective, right?
Well, the algorithms themselves are just math, right? But the data they're trained on, that can reflect biases that already exist in society.
So if you train an AI on biased data, it's going to learn to be biased itself.
Exactly. Imagine an AI that's deciding who gets a loan or who gets a job interview. If the data it's using is based on past discrimination, The AI could end up making biased decisions that hurt certain groups of people.
That's really worrying. We need to be extremely careful about the data we use to train AI systems, make sure it's fair and represents everyone.
Absolutely. And we have to be aware that AI can be misused too, intentionally or unintentionally. Think about AI being used for surveillance or even to control weapon systems.
Machines making life or death decisions, that's scary, like something out of a dystopian movie.
It's something we need to think about seriously. Who's responsible when something goes wrong? What happens if we give machines too much control?
It's a lot to process, so many potential benefits and risks. Utopian dreams and dystopian nightmares. It's all wrapped up in this conversation about AI.
It's complicated, for sure. Easy to feel overwhelmed. But remember, we're not just passengers on this train.
Yeah.
The future of AI is not set in stone. It depends on what we do.
So we can't just sit back and watch. We have to shape how AI develops and make sure it's used for good.
That's right. And in the next part of our deep dive, we're going to look at some of the initiatives and organizations that are working towards a more responsible and beneficial AI future.
We've been on quite a journey, haven't we? Exploring the origins of AI, the potential for a singularity, and some of the very real problems AI is creating right now.
A lot to think about.
It is. But even with all these challenges, it's kind of reassuring to know that there are people out there, brilliant minds, who are trying to steer us towards a more responsible AI future.
That's a good point. There's definitely a growing awareness that we need to go beyond just building the next cool AI gadget.
Right, like we need to think about the ethics, the impact on society, make sure AI is used to benefit everyone. So let's talk about those efforts. What are some of the things people are doing to make sure we use AI wisely?
Well, what's really interesting is seeing people tackling both the long-term and the short-term challenges.
Okay, what do you mean?
So on the one hand, you have these groups like the Future of Life Institute, FLI, and the Center for the Study of Existential Risk, CSER. They're really looking at those big what-if scenarios.
Like, what if we actually create super intelligent AI? What then?
Exactly. They're asking some tough questions like, how do you make sure AI, even if it's smarter than us, still has our best interests at heart? They're funding research on AI safety, holding conferences, talking to politicians, trying to get everyone thinking about this stuff.
So sort of like planning ahead, putting guardrails in place before we need them.
Exactly. But then on the other hand, there are all these initiatives focused on the problems AI is causing right now.
The real world stuff,
Right.
not just preventing some hypothetical robot apocalypse.
Right. There are organizations trying to come up with ethical guidelines for developing AI. They're checking algorithms for bias, creating tools to help us understand how AI makes decisions. And they're pushing for laws and regulations to make sure AI is used responsibly.
It's like AI is already out there in the world having a real impact, so we need to make sure it's a good impact.
Exactly. And the encouraging thing is, it's not just talk. Things are actually happening.
What do you mean?
Well, some governments are looking into creating regulations for AI, like similar to the rules we have for other powerful technologies, pharmaceuticals or nuclear energy.
So treating AI development like something that needs serious oversight makes sense.
It does. And it's not just governments. A lot of tech companies are coming up with their own ethical guidelines for AI.
They're realizing that building AI people can trust is not only the right thing to do, but it's good for business too.
Makes sense. Who wants to use a product or service that's biased or unfair or totally mysterious in how it works?
Exactly. Trust is huge, especially with technology that's becoming such a big part of our lives. So how do we build that trust?
Well, that's where explainable AI comes in.
Explainable AI.
Yeah, it's about making sure we can understand how AI systems make decisions. Not just accepting the output blindly, but being able to look under the hood, so to speak.
So like understanding the why behind the what.
Right. And that's key to building trust, spotting bias, and making sure someone's accountable if things go wrong. Imagine like an AI deciding who gets a loan or who gets parole. Do you think you'd want to know how it made that decision?
Oh, absolutely. Without transparency, it's just a recipe for disaster.
And another really important thing is collaboration. It can't just be AI researchers working on this stuff.
What do you mean?
I mean, we need ethicists, sociologists, lawyers, philosophers, even artists and writers. We need everyone's perspective to figure this out.
Like, we need all hands on deck. A whole team of experts to make sure AI is actually benefiting humanity.
Exactly. The future of AI is way too important to leave to just one group of people. So after this deep dive into AI, where did that leave us? We've looked at its history, All the potential upsides and downsides, the philosophical questions and ethical challenges, and all the stuff we need to figure out.
A lot to unpack. So what's the bottom line?
I think the most important takeaway is this. AI is a tool, a powerful tool. But it's not a magic wand. It's not inherently good or bad. It's what we make it. It reflects us, our creativity, our values, the choices we make. The future of AI is what we decide it's going to be.
That's a powerful thought. It means we all have a responsibility here, right?
Well, it doesn't matter if you're a developer, a politician, a business leader, or just someone who's concerned about the future. We all have a role to play in shaping AI.
So as we wrap up this episode of The Deep Dive, here's a question for you to think about. If you were designing an AI system, what would be your top priorities? What safeguards would you put in place? And what kind of future would you hope to create with it? Thanks for joining us on The Deep Dive.